What version of an AI future do you imagine? Is it utopian, like say it is in Star Trek, where the AI is friendly, conversational, and Siri-like, promising indefinite lifespans, freedom from work, companionship, and entertainment, helpful and approachable, but always under human control? Or is your version dystopian, like The Matrix, Minority Report, and every episode of Black Mirror? Science fiction films usually tend to focus on the most negative aspects of AI as something of a warning sign, alerting us to the risks of how things can go wrong. A robot that turns on its master, the rise of the machines against humanity, or a society where the machines have already won. Utopian or not, AI is a recurrent theme in science fiction, but that's just fiction, right? What about science fact? Well, it turns out that there's no consensus today on what an AI future will look like. Look at, for example, the tech titans, the very people that are leading the efforts and investing billions in this area of research. Between them, they don't agree. Even researchers, computer engineers, roboticists, physicists, social scientists that work in this field, they don't agree. The world's second richest man, Elon Musk, whose SpaceX program plans to land humans on Mars by 2024, he's exposed to the most cutting-edge AI, and yet he thinks that people should be really concerned by it. He believes that AI poses a fundamental risk to the existence of human civilization. Mark Zuckerberg, on the other hand, thinks we shouldn't get so negative about it and is actually very optimistic. And his view is shared by many scientific and academic minds who think that climate change, the spread of nuclear weapons, virus mutations, political unrest, they're much bigger things to worry about than being enslaved by AI. So fact or fiction, no one can quite agree on what an AI future will look like. So what do we know about AI, and should we even care? Well, let's briefly recap on what AI is. The CSIRO defines it as a collection of interrelated technologies used to solve problems autonomously and perform tasks to achieve defined objectives without explicit guidance from a human being. A bit of a mouthful. Basically, programs that carry out tasks without constant input from humans. Some of the technologies to listen out for here are things like machine learning, which gives computers the ability to learn, text, voice, and speech recognition, computer vision and biometrics for taking images and organic samples. And finally, robotics, which brings all of these things together to carry out complicated tasks in a physical environment. Now, if you're wondering what the big deal is, one government study finds that AI is potentially worth $315 billion to the Australian economy by 2028. And that's only a few years away. When you consider that the developed economies like Australia's have been slowing down in the past decade, AI could very well be the shot in the arm that turns things around and starts to deliver really strong growth again. And this is from doing things like, helping people with health problems, identifying cancers early, helping the aged, helping grow more food, helping business owners manage their costs, improving the climate, even spotting fake news. There are many other great examples of companies in Australia and overseas developing life-improving AI. And these are happening right now. On the downside, there's a real and imminent threat that the AI revolution will take away jobs. The US lost around 40 million jobs at the height of the COVID pandemic. And while some of these have come back, others will never return. One group of economists estimate that 42% of these jobs are lost forever. AI can also lead to unfairness or bias, and this has already been observed in the criminal justice system, in advertising, in recruitment, in healthcare, in policing, and elsewhere. And then there's just the plain awful products that should not even exist. Apps like deep fakes or deep nudes that present images or videos of things that never quite happened. Or apps that try to guess your sexual orientation, your gender, your race, your likelihood of being a terrorist based on things like how you look or how you walk or how you might spell your email address. So with the promise of the good and the risk of the bad, how do we get the balance right? How do we create responsible AI? It's quite simple. If we want responsible AI, we need responsible people working in AI. And the only way we're going to get that is if everyone has a say in what AI gets built, how it gets built, and where it gets used. We need diverse voices, people with unique interests that can get involved, kids that might otherwise pursue the humanities, the arts, justice, well-being, drama, the social scientists. They too need to get involved. We can no longer afford to leave technology decisions to the technologists alone. Essentially, we need everyone to have a say. And the only way to do this is through increasing data literacy. Now, data literacy refers to our ability to understand, generate, and use data. This can mean everything from being able to sort through the results of a survey to being able to understand the meaning of a complicated graph or a chart. 90% of the world's data has been created in the last 2 years. With all of the billions of smartphones and wearable technology and the amount of time that we spend online, the amount of data available has exploded. Now, this is the very data that's being used to develop AI. By ensuring that we have the data right, that we understand it correctly, we can be confident in developing responsible AI that does good. If you think data literacy sounds a bit complicated, I want to show you that it's not. In fact, it's really, really easy to get started, and you can do it with little effort or any planning, as I discovered on a drive to school one day with my 7-year-old daughter. It started off as a conversation about why there are so many different shapes of cars on the road. And then we started talking about the badges, the logos, the symbols on the front and the back of the car, and the fact that they represented the person who makes the car. And then this morphed into a game of counting all the cars that had a Toyota badge. This game kept going on for a few days. I then suggested that she might want to make a note of what we were counting on each of the different days. When she had collected a few weeks' worth, we looked at the numbers more closely. We then did some sums, we looked out for patterns. This whole process turned out to be so rewarding and so fun that my daughter presented it to her class via a Zoom call. When I sat back and thought about the process that we went through, it's not really that different to what happens in business and research every day. So before anything else, you need to decide what it is that you want to explore or understand. In our case, the subject of interest, the thing or the phenomenon that we wanted to learn more about was counting Toyotas. You might want to try it with something else. Maybe try, there are so many activities, so many ways you could do this. You could try counting different colored crayons or textures or pencils in the house, counting jelly beans in a jar, counting the number of forks and spoons in a kitchen drawer, or counting the number of flowers in a garden. We could have picked any brand of car, but we decided on counting Toyotas. With that in mind, the first step is to start collecting the data. That is making the observations, the actual process of counting itself. Counting can be as straightforward as making a note every time you observe your subject of interest, every time you see it. Now, these observations need to be stored somewhere. If we keep them in our working memory, they're probably going to be forgotten. Data storage is the process of documenting an observation for retrieval and usefulness down the track. In our case, the observations were recorded in my daughter's unicorn notepad. They were organized in 3 columns, where each new line or row represented a different day. Each daily observation was recorded in sequence, written below the previous day's count. After collecting about 3 weeks worth of data, it was time to start exploring it, to look for interesting patterns that might appear. This was prompted by basic questions like, which day of the week do we see the most cars? Did we see more cars in the first week, in the second or the third? Which day had, had the maximum number, of cars that we counted? The next part was to turn the numbers that were written down into a picture that could show us things, patterns that were not instantly obvious just by looking at the numbers alone. This made it really easy to see things like on which days we count the most cars, which days did we count the least, and how does that vary from day to day. This is by far the most creative, most fun part of the process, as there are numerous ways to display this information, to pick what information to display, how to color it and how to label it. With all of the counting, summing, and graphing completed, the last step was to present the information to an audience. This step in the process tied everything together. This was the way of being able to tell a story, to talk through what we did and what we learned about it and the so on. And it's crucial that the data and the findings from this can be explained in a way that anyone can understand. It's getting to this explainability that makes data literacy generally such a vital skill. And explainability really cuts to the core of creating responsible AI. This step also allowed my daughter's classmates to ask her questions about what she did and what she learned, which helps them on their journey in data literacy. Getting kids to talk about data amongst each other reinforces data literacy and makes them more fluent and naturally able to work with data. So there you have it, preparing our children for an AI future with basic data literacy. A process that's actually not so different to what most companies and researchers are carrying out day to day. If we want responsible AI, everyone should become data literate. While traditional literacy helps us read and understand others' interpretations, data literacy helps people think and arrive at conclusions on their own. This is a foundation for a society built on rational and independent thinking and one in control of their technology. And from this, we can build an AI future that we can all look forward to. Thank you.